Good evening, everyone. Once again, to our audience on YouTube, we are currently live. If you can just confirm if we are audible. All right, everything looks good. Once again, good evening and welcome to today's session on simplicity in battery assembly. Our speaker for today is Sandeep from Sika, India. Without over ado, over to you, Sandeep.
Okay, thanks so much, Anita. Once again, good evening, everyone. My name is Sandeep, and I'm the National Sales Manager for e-mobility business in India. Uh, some of you might have met me during the Formula Bharat event. If not, obviously, I mean, we can definitely catch up in the following events as well and during the Q&A session post this. So the primary objective of this session is to educate you guys on the various solution that's available for the battery assembly. So that includes the structural adhesives, the thermal management, and fire protection. So to give you a background on what is Sika, hold on. Yeah. So Sika is basically a Swiss company, primarily into the construction business. Globally, we are present in more than 100 plus countries, and in India, we have been here since 1987. We have two main verticals. One is basically the construction division, and another one is called the automotive and industry. So I am basically from the automotive and industry, which caters to your e-mobility business, transportation, which includes the your train and bus and trucks, then the passenger vehicle business, two-wheeler and three-wheeler, solar and wind, and as well as the general industry. To look at the numbers per se, we have close to about 220 patents as of 2025, and we are about 14.5 billion as on 2025 sales. Coming to the target segments, what we have, like I mentioned, we have eight main target segments, out of which seven caters to the construction industry, which includes your concrete mixers, waterproofing, roofing, flooring and coating, sealing and bonding, refurbishment, building furniture, etc. But we are basically from the industry portfolio, wherein, like I mentioned earlier, caters to the passenger vehicle, then your trucks and buses, trains, solar and wind, etc. In India, we have seven plants, out of which six caters to the construction industry, primarily for the concrete mixers and waterproofing and flooring adhesives. Whereas the automotive and industry plant is based out of Chakan, which is basically the hub for, automotive industry, and wherein we have a fully fledged production facility for polyurethane, epoxy, and silicon sealants and adhesives. We also have the thermal management, potting, and thermally conductive adhesive manufacturing in the same facility. One good thing which you can probably utilize is we also have a lab and an R&D facility wherein you can always visit us for any kind of testing and validation and any kind of product requirements. Coming to the today's topic, so like I mentioned, I don't want to go into detail about the other segments. As far as e-mobility is concerned, Sika is fairly new compared to few of our peers in the industry. We started this business in 2018-19, and in India we started this in 2022, late 2022. As of now, we supply to about three OEMs, which is into the four-wheeler business, and we supply to about six two-wheeler OEMs and few other energy storage companies. So I don't want to go in detail about this because you pretty much know, probably you know better than me in terms of the applications where the batteries goes into. The only difference I would like to, stress over here is that over the last 2 years, there has been a lot of focus on the energy storage systems. And most of these batteries that goes in for the passenger vehicle, be it two-wheeler, three-wheeler, or the four-wheeler, or the trucks for that matter, has been going into the energy storage system during the end of life. The fact of the matter is, in India, it's still new. I mean, we might probably need another 7 to 8 years for these batteries to get into the energy storage system. But as far as the design is concerned, reworkability, recyclability, and I mean, material extraction from the battery packs and all these things are new technologies that's coming up as far as battery design is concerned. So, I don't really want to take you through too many slides and different things to make it boring. So we have a small video. It's a short 5 minute video, basically, which shows all the applications what we have as far as battery assembly is concerned. So this, what you see over here, is a passenger vehicle liquid cooled battery pack, very similar to a Tesla architecture. If any of you would have seen that video in YouTube. So I'll start this. So what you see over here, the red one is basically a structural adhesive. So typically a conventional battery pack is made with welding joints and other mechanical fasteners. But the fact is that you can also do the same thing with structural adhesives, which gives equal or even better strength than a welding joint. Like I mentioned earlier, this is a liquid cooled battery pack, and what you see over here, these are the cooling channels. And the blue one that is being applied is basically a coolant resistant sealant, which basically gives you IP67, 68. At the same time, it does not react with the coolant. So we have different products in this particular range. So depending upon the type of coolant that is being used in the battery pack, we can decide on what product needs to be applied. Then comes the battery bottom plate, and the side walls are fixed on the structural adhesive. So this is basically something called a thermal runaway protection coating. So we call it this the intermission coating. These are applied not generally between the cell, but I would say 99% of the current OEMs apply it underneath the top plate, the battery top plate. So if you look at any thermal runaway situation, typically the top plate becomes the weakest point and that kind of explodes. You'd have seen multiple videos on this. And the reason for that is because, I mean, aluminum casing typically gives away at about 650 to 700 degrees Celsius. So this coating, it's called an intermission coating. So what happens is, in the event of a thermal runaway, and as soon as the coating comes in contact with the flame, this starts expanding and creates a barrier. It creates a foam. So this has an expansion factor of about 50x. So let's say you apply for 1 mm thickness, this can expand up to 50 mm, and that creates a barrier between point A, I mean the fire side and the non-fire side. So this will not prevent thermal runaway, but this will only, I mean, elongate the process. So let's say if you apply this in a passenger vehicle, underbody or on the battery top plate, typically what happens is you get sufficient time for the passengers to be evacuated. And this is a cell to structural bonding, which is basically a structural adhesive. It can also be a thermally conductive adhesive based on your design. This is cell to plate bonding, thermally conductive adhesive again, which currently we have something called Sika 326CV. In fact, some of you are already using this product. And then we have the Sika Flex series, which is for the battery lead sealant, which gives you the IP67, 68 rating. Now coming to cylindrical cells, you have the same product, which is basically the thermally conductive adhesive, which is for holding the cells to the cell holders. And then we have the bonding solution, which can give you up to 1.2 watt per meter Kelvin of thermal conductivity. And in that case, then you don't have to use any other thermal, I mean, interface material. And the lid is sealed again. Now, this is a thermal paste solution. the main difference is that if you are going with a thermally conductive adhesive, it's a non-removable solution. So, like I mentioned in the beginning of this session, a lot of companies do ask for a removable solution. One is for the repair, and second thing is on the recyclability part. So, thermal cap fillers are different from thermally conductive adhesive because thermal cap fillers have more thermal conductive fillers in it compared to less fillers in a thermally conductive adhesive. So I would say thermally conductive gap fillers will have 80% conductive fillers and 20% adhesive, and vice versa in the case of a thermally conductive adhesive. So in this case, thermally conductive gap fillers can go up to 3.5 watt per meter Kelvin of thermal conductivity, but with a very, low mechanical strength. So if you're using a thermal gap filler between the cell and the bottom plate, you need to have additional mechanical reinforcement. Then comes the battery top plate. Like I mentioned earlier, is coated with a intumescent coating from the inside. Then you have these. Coming into the motor, we have some epoxy resins, high temperature applications for the motor coil potting, and also thermally conductive potting for the BMS. So that's the overall portfolio what we have from Sika as far as the battery assembly is concerned. So I'll go in a bit detail in the following slides. So like I mentioned earlier, it's basically sealing and bonding, lightweighting, thermal management, and cooling management with all these products. So if you look at the applications, it's basically structural adhesive for tray bonding. Then we have the sealing of the cooling plate in case of a liquid cooling system. Then we have the seam sealing for tray and lid sealing. The fire protective coating, which is the intermittent expandable coating for the lid. Then thermally conductive adhesive for cell to plate and as well as cell to pack applications. Then structural adhesive for cell to module. Thermally conductive gap fillers as well as potting material for the cylindrical cell. So these are the overall portfolio what we have. Now coming into the detail. So first thing is, like I mentioned earlier, you can get rid of your welding joints and any other mechanical fasteners and go with a very strong structural adhesive or epoxy adhesive for your battery tray manufacturing. So these are typically epoxy based and polyurethane based material based on the strength that you're looking at. So this can give you a tensile strength of almost 22. We also have some Sika power products that can go up to 45, megapascal. So this is something which is used in your wind blade applications and all, which has now been, transferred to the battery technology as well. The only difference is that, when you compare the material that goes into the battery and the other industries, is that most of the 99% of the products what we offer for the battery is all UL 94 V0 rated, whereas what is being applied in the rest of the industry is not UL 94 V0 rated. So I think that's one key parameter I think you also look at when you select the right material. This video basically shows the working battery. then next is the cooling system, which is basically the Sika Flex 953 series, which is primarily again a STP, saline terminated polymer plus a booster material. So so typically if you look at any kind of adhesives or sealants, the curing is by absorbing the moisture from the atmosphere. So in this case, in Sika's case, we have a patented technology called a booster system. So booster is something with an additional nozzle, which basically injects the moisture into the same adhesive, and this can give you a very low, curing time. So typically, a standard adhesive can take anywhere between 4 hours to 24 hours for 100% curing and gaining strength. Whereas if you're using a booster system, this can be as low as 30 minutes or even 20 minutes. Then we have the general tray sealing, which is basically for the again, IP 67, 68 rating. This is not used for the coolant application, but for the general tray sealing where it is not in direct contact with any kind of fluids. Then there is a lid sealing, which is a permanent sealing application. So this is again, one component polyurethane based material, which is basically used for the top lid application. So a lot of people also might go with an FIPG or a CIPG solution, and then you go with a mechanical fastener. The only difference in this particular solution is that, this is a non-removable bond. But there are quite a lot of OEMs who are already using this material because a lot of people doesn't want the battery to be opened by a third party. So in that case, you can go with a permanent bond. So how do you open this? So basically, in those cases, what happens is you can go with an oscillating tool, and this can be easily opened. A similar adjacent example, which I would like to give here, is your windshield bonding. If you look at your car windshield, typically that's a polyurethane adhesive that's at the corners. And I'm not sure how many of you have seen the windshield removal. It's just with a wire and then you just pull it off. With a similar application, we can even remove this battery top lid seal with a polyurethane based sealant. Now coming to the another important topic, which is the fire protection coating. So, as you know, thermal runaway can be due to multiple reasons. It can be because of a short circuit, it can be because of overcharging, it can be a mechanical defect, or it could be an accident or a crash. So, typically, the global standard for the fire protection is called GTR 20, which came from the European Union, which means that, and which says that, there should be an at least 5 minutes escape time post the warning given to the driver. So in the case of a passenger vehicle or even a two-wheeler or a three-wheeler, it's pretty much practical to do the evacuation under 5 minutes. But when it comes to a public transport like a bus, where typically the pack is at the bottom platform, and let's say in the case of an accident scenario, it becomes extremely difficult for the passengers to get out of the vehicle under 5 minutes. So that is the reason we came up with this particular product called the intumescent coating. So like I mentioned, it's a 0.6 to 1 mm thickness is what is recommended by Sika. And during fire, what happens? It foams up and creates barrier of about 30 to 50 mm. So it has got an expansion factor of about 50 times, provided you have the space for the material to expand. So that creates a barrier between the fire side and the non-fire side, and which delays the whole process. So if you look at the, fire test results, which I can share with you if anybody is interested, there is a clear delta T of almost 400 to 500 degrees between the fire side and the non-fire side. And during thermal runaway, temperatures can go beyond 1,200 degrees Celsius. And even after then, during that time, the non-fire side temperature would be way less than the melting point of aluminium. So this is a short video about, how the material reacts during fire. So what you see over here is without coating on the left hand side and with coating on the right hand side. So as you can see, aluminium starts giving up in about 12 to 13 seconds, whereas the intumescent coating will start expansion. Like I said, the moment the coating comes in contact with fire, it starts expanding and it creates a foam barrier. And this Sika cut material can be applied to any substrate. I mean, it's not just limited to metal, but it can be applied to, I mean, other engineered plastics or wood or, even any other material as well. Because the fundamental idea is that it creates a barrier between the fire side and the non-fire side. So this particular, I mean, material can withstand 1200 degrees Celsius for up to 30 minutes. And this is being extensively used by many of the vehicles that you currently see in the market. So I will not play this video because I'll explain this later. So the product name is called SikaGuard 839, which is basically a epoxy-based solution. And like I said, this has got a curing time of almost 24 hours, but this can be accelerated. If we put this in hot oven for almost 4 hours in under 60 minutes, we can get a completely cured material. And the working temperature for this is minus 42 plus 80 degrees Celsius. Coming to cell to plate bonding. So, like I said, we have two products here. One is for the cell to bottom plate bonding, which is called Sika Force 326 CB. It's no more 325 CC. Now the name has been changed to 326 CB, which is a better product in terms of stability. Like I mentioned earlier, some of you are already using this. So this comes with a thermal conductivity of 1.2 watt per meter Kelvin and a strength of almost 14 MPa, so 11 MPa. And the second product, what you see over here, Sika Melt, is basically for the cell-to-cell bonding. So in the case of a prismatic cell, Sika Melt can be used, and this is also a removable product. So this is more like a pressure-sensitive adhesive that can be applied between the cells to keep it mechanically bonded. Both these products are UL94 V0 rated, and 326 CB, like I mentioned earlier, is a non-removable bond. So the only way you can remove the cells is by destructive methods. Then comes the structural bonding again, which is basically for the cell to side wall thing. So in this, we have the Sika Power and the Sika Force series. So over here, you can see the tensile strength, which goes up substantially to almost 42 MPa. Now comes the potting. So potting is something which was used, I mean, quite extensively in the market until about a couple of years back. I mean, especially in the case of cylindrical cells. So a lot of people, a lot of OEMs doesn't really want to go with potting now because potting adds a lot of weight to the whole system. But this is still relevant when it comes to energy management. So the battery energy storage systems, a lot of people to get rid of the rest of the thermal management material like adhesives and even your intumescent coating, you can just fill up the entire battery pack with a potting material. Again, potting, we have removable as well as non-removable solutions in this. So the 786 series, what you see, the second one is basically a soft polyurethane-based material which can be cut. It's very similar to rubber and can be easily removed in case you want to rework on the battery or replace a cell. The same material can be used in your battery management system, the BMS, or any component for that matter, wherever there is any kind of heat that needs to be transferred. So the potting is also used in LED light applications and a lot of other automotive applications like your displays, the display, what you see inside the car and even your electronics like your phone and iPads and all, they use this kind of material. Then comes the gap filler. Like I mentioned, gap fillers are removable material, and this has got very low mechanical strength, probably about zero point 0.1, zero point 0.2 MPa compared to 11 and 15 and above for the thermally conductive adhesive material. But thermal conductivity for thermal gap fillers are pretty high. It starts from 2.2 and goes up to 3.5 watt per meter Kelvin. There are other material available in the market which can go up to 6, 7 as well, which primarily goes into your electronics application. So this particular product is in a paste form and will remain in the paste form throughout the life of the battery pack. So that's the beauty of this product. So I'll take you through one more video which basically explains a bit more in detail about these products, what I explained until now. This is a thermally conductive adhesive for cell to bottom plate. Similarly for the cylindrical cells. These are the thermal gap fillers, the removable. flexible frame basically. So this experiment basically shows, how fast this material transfers heat from the heat fan onto the ice. It basically melts faster because, the Sika thermocapacitor interface with 3 watt per meter Kelvin. So this is how the thermal capsules are injected. So this video basically shows, that it can go up to gaps below 1 mm. It's a completely flowing material. These are the thermal interface material. Starts on TC455, 2.2 watt per meter Kelvin thermal conductivity. Then you have this TC45, which comes to 3.5 watt per meter Kelvin. And then this is a sealant, basically complex 963 TC.
Sika's structural adhesives support a range of battery applications, from increased crash resistance to joining multi-material enclosures. Sika's flame retardant and electrically resistant adhesives bond cell stacks to module frames quickly, with a minimum level of elasticity to allow cell swelling. The top cover is finally assembled with a sealant. Sika's booster technology enables rapid end-of-line pressure testing, ensuring a durable, lifetime seal for battery packs.
This is a world sealant application. So this is primarily used for the battery box or the pack manufacturing, where we have the welding joints, and all the rest of the caps can be sealed with this world application. This gives you the intended IP61 3A rating without adding too much of weight, the welding weight onto the pack. We also have the foams basically. I mean, these are expandable foams. So wherein you fill in about 30% of the pack with the liquid material and then expands and fills up the entire pack with the foam. The only problem with the foam is that doesn't really give you any kind of thermal conductivity, but it's a good fire barrier and also doesn't add any kind of weight, unlike a potting material or a thermal gap filler, which is pretty high dense material. And this is the immersive coating, expandable immersive coating. Many of the OEMs, in fact, coat the entire inside of the battery pack, like you see here, with this particular intumescent coating. And the same coating is being used in railways as well. If you look at the new Vande Bharat coaches, they have a lithium-ion battery pack at the bottom, and the entire battery box from inside is coated with intumescent coating. But there you will see a much better video wherein how this whole material expands until it explodes in the flame. So you can see that the substrate is completely intact. That's pretty much on the products what we currently have. Going forward, we are also launching few new products this year. So one is obviously for the tray sealing, which is primarily going to be a foam in place gasket. So there's a lot of demand in the market for easily openable battery lids. So we would be launching a foam in place gasket this year. Apart from that, we have already launched a foam material, which is again primarily for the cylindrical cell application. And some of our thermally conductive adhesive and the gap fillers, there will be uh, the same product but with a reduced density. So basically, that will reduce the overall weight that goes inside the battery pack. So, and then coming to some of the structural adhesives, because now there is a shift from, cell to module to cell to pack, and then now cell to chassis. So there is more and more importance for the structural adhesives to be implemented inside the new battery packs. So yeah, that's pretty much from our side as far as the solutions are concerned. Thank you so much.
Thank you, Sandeep, for the presentation. I believe we are now open to Q&A. So to our participants here on Zoom, you can feel free to unmute yourself or probably put your questions in the chat box. And even to our audience on YouTube, you can just put in your questions on the chat box and we'll get them answered.
So if you don't have any questions right now, that's okay. I mean, you can always reach out to me by email or by phone as well. I mean, I think Renita, I think you would have probably already shared my contact details, right?
Yes, we can share it on the group. I can also put it
Yeah.
up on the chat now. All right. Looks like we don't have any questions. So I think Sandeep already addressed that if you are interested to, gain support from Sika or collaborate with them in any way or have any questions, you can feel free to reach out to them. I will be sharing Sandeep's email ID with you. I think that should be helpful. Is there anything else you want to add, Sandeep?
No, nothing much. Thank you, Ranita, for this opportunity.
Thanks, Sandeep, for taking all the
Looking
time.
forward
Yes,
to all the, questions and support from the team.
definitely.
Yeah.
Definitely. Thank you once again. You have a good evening.
Thank you. Same to you.